Hello, this is a recording of how to set up the Carel pRack for the chiller application. When you turn on the Carel at first, you'll have this wizard. Start off by entering the wizard. We're doing suction and condenser control because we're controlling the compressors and the condenser. So we scroll down, degrees Celsius and bar. Reciprocating compressors. We can open up our wiring diagram. We can have a look at how many compressors we have, which I could find if this wiring diagram was good, but it sucks ass. How many compressors do we have? It's compressor number 2. Compressor 1. Compressor 3. Okay, so I go back 3 compressors. Number of alarms for each compressor. Have a look at the wiring diagram again. You can see we've got HP, motor, or failure. 3 inputs into the PLC. So we can enter, 2, 3, enter. Are we controlling the speed? Yes. Inverter for the first compressor. Compressors are the same size. We can configure the stages. So if you have a look here in the wiring diagram, again, you'll see we are controlling some unloader valves for the compressors. As such, we come in, we say 166.33 for the compressors. Oops. Does not want to do it. Oh, because compressor 1 is with an inverter. Okay, there we go. Okay, compressor 1 inverter, compressor 2, S2, S2. So you can see here, oops. We don't need to. S2 is definition 2. S2, S2. But 404A, we'll control this one using neutral zone. Set point. We're going to control this to approximately -3. So we'll just get our slide rule out. And that's going to be about 4.4 bar. So we go about 4.3 bar. Differential of about 0.4. Only got one condenser. We do not have, we have one fan because we're controlling an inverter only. Yes, we control the condenser fans. The condenser fan, sorry, is here proportional. We'll roughly control the condenser pressure at 17 bar with 2.5 bar differential. Now the condenser lines, That's all on board. Let's see, push enter. That is the basic wizard setup process. Then we have to get into the detailed setup. Okay, enter. First, let's get in and program up the various settings. Compressor, in the regulation, neutral, you just leave the range. Actually, we can come here and make sure that somebody doesn't set this too cold, otherwise it'll just freeze. So this is very important, the differential, the activating zone and the deactivating zones. Actually, we should take this down a little bit. This is essentially a pump down. If we get to 1 bar, the system will shut down. 100% power load to 100%. We only want this to load slowly. We have no reason for this to load quickly. The reason we're putting this is, so it's saying that when the suction pressure is high, it will take between 60 seconds and 180 seconds to load up all 3 compressors. We have no reason for this to load up any faster than 60 seconds to 180 seconds. But unloading, we do need this to be able to unload reasonably quickly, otherwise it will hit a vacuum. So we do let things unload a little bit faster. Don't need any of these, and done. Next. Alarms. Oh, sorry, this is a high suction pressure alarm. We don't want this alarm, it's annoying actually, so just wind it up. If we have an alarm on the inverter, switch the inverter off. We don't actually manage the superheat using the Carel, we do it separately. Okay, so overload number 1, again, let's have a look at a wiring diagram. Number 1, alarm, pressure, motor, oil. So come back, alarm 1. Is a high and low pressure. We just put a couple of seconds delay on the pressure alarms. We let it automatically reset and have it as a series. Remembering our high pressure will not automatically reset anyway. Number 2 was motor. Again, having a 2-second delay will stop nuisance alarms. And number 3 is oil. don't. Configuration, 3 compressors. Minimum on time, we don't like to set a long minimum on time for a compressor. This can lead to over pumping down, and it can lead to hitting vacuums and running in vacuum. So we don't want to do that. Off timer start to start. 6 minutes is fine. Okay, so load up time, how long it takes between turning a compressor on and loading up a different stage. Again, we just want to drag that out. We don't want to increase it. The lead compressor, we're only going to run it to 50 Hertz. Again, we'll wind down this minimum on time because we really don't want to pump down into a vacuum. Conversely though, we don't want the compressor to stop and start too quickly. So let's wind up this time a little bit. Even though it's got an inverter, we want to protect this compressor from starting too frequently. So this is not really that important because all the compressors are the same size. If we had different size compressors, it would be important. So you can just leave that the same. It's really not going to make a difference. Inverter, and then compressor 2 has different valves. We can see which type inverter and type 2. That's it. Advanced. The inverter is going from 0 to 10 volts. We'll have a raising time. You have about 40 seconds. And falling time of 5. This is very important. We want to modulate the compressor inside the neutral zone. If the pressure goes below our threshold, we do actually want to keep the system running for a while. So the threshold is we'll let this compressor run for a few minutes below the normal pressure of the system while it's waiting for things to balance. Otherwise, it sometimes will just pump down too quickly. That's it. Condensers. Regulation, we've already set our set point. That's just a high pressure alarm. Wind down this low condensing threshold. We really don't want this. This can be a nuisance on cold warnings. So turn that down. One fan only. Advanced. This is important. EC fans only run 3 to 10 volts. They do not run 0 to 10 volts. Make sure you change that to 3. And the operation is, in fact, %10 to 100%. what we can do is we can buffer out this rising time so that our fans don't launch up. We really have no need for the condenser fans to accelerate too quickly in this case. That's all. We should set up the clock when it's on the job site. Safety, as is nice. High pressure prevent, lovely. Stops the unit if we hit 21.5 bar. Turn the pressure down. We really don't need a long delay where we ignore low pressure alarms on the system that we're doing, and we'll allow 5 resets within 1 hour and 20 minutes. Now that we've done that, we've basically set up all the major items. Now we come to inputs and outputs, status, digital inputs. So if we have a look at our wiring diagram here, where is it? This one. So we can see HP, LP, HP ID1, LP ID2. So common low pressure ID2. 2 should be normally closed. High pressure, I1. Just have a look. Can't see if that's normally closed or normally open. We'll assume it's normally closed. Okay. Inverter warning. Where is the inverter? Compressor 1. Where is the inverter? Where's the inverter being put? We have ID6. Let me close that. Alarm 1, compressor 1. Compressor 1, oh, alarm 1, 3. Compressor 2. Oh, alarm 2, compressor alarm 2, compressor 1. 4 and then 5. 4. 5. Alarm 1, compressor 2. So is it 7, 8, 7, 8 and 9. Alarm 1, compressor 3. Is it 11, 12, 13. Now we have a look. Come back. We have no other IDs. IDs here. Let's go to the next page. Do we have any other IDs? We should have no other inputs. Check, 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 check. And these are no other inputs. These are now our outputs. So you can scroll down. None of these are used, so you can see we don't program them. Go back. Digital. We can go here. Analog inputs. Come back here. Yeah. Analog inputs. So we have the suction gas probe U1, discharge pressure U2. You just have to check what we've actually used, whether it's a 0 to 5 volt or what. And here you have to match the type of probe with that. So just check on the system and match it up. Recording. One sec. Same condenser probe. Oops. Condenser probe U2. Same thing here. You've got to choose which type of probe it is, and you've got to put the values in there. You're just going to have a look at what's installed on the rack system. They're the only two ones in. Then we come down to digital outputs. So compressor 1. If we look on here now at our outputs, you can see compressor 1 is NO1. NO1. Oops. There's not open. Compressor 2. NO4. Compressor 2 unloader 1. So compressor 2 unloader 1, 5, and then we've got 6. Oops. 5. And I'm not too sure on this one whether it's I think it's energized to unload. So the logic is in this case is going to be normally open. Oops. Okay, and compressor 3, we're going to look down here. Compressor 3, signal 7, 8, 9. 7, 8, 9. We don't use the fan control because we're using the 0 to 10 volt. If we come in here, you can see we do have normally an alarm output, which is, we'll come here, abnormal alarm on 15. So we're going to scroll down, global alarm output, 15. And the logic is normally open. And active, yes, we have active alarms at the moment, so it shouldn't be a surprise that that's an alarm. Okay, last but not least is analog outputs, inverter. So if we go back to our first page, you'll see here, where is it? Y, 0 to 10 volt to frequency converter, Y1, Y2, 1, and inverter fan 2. Now that's basically the unit complete. It's configured. We come to unit status and we can turn the system on and off. What you might like to do before that is if you come into inputs and outputs, and you can come into test, analog outputs, you can test your condenser fan. Or you can come into manual management. So here we can go to analog outputs, discharge line, not the suction line. We can enable this for 10 minutes. We can come here and we can force the fan to something, example like this. Oops. Enter. Now the fan should run to full speed and we can check our condenser fans. And after we've checked our condenser fan, we can go back. We can turn this off. And come back to the home screen and we're ready to go. Of course, this is not working for me because I'm using a simulator, and on my simulator, I don't have any pressure probes connected. So it's just coming up with an error. All right, so that's basically the configuration of that. If you push enter on your screen, you can scroll down through and see when compressors are going to start and stop. We can see which compressors are in operation, how long until the next compressor will start. We can have a look at our condensing pressures. We can have a look at fans running the output to the condenser. So we can see the 0 to 10 volt output here. And we can measure the voltage on the output to confirm that. And that's basically the setup of the pRack. So thank you very much.